Once the proposal becomes a project and a PO is issued, it then enters the engineering and procurement phase of the equipment supplier. Learning objectives for this phase is to first understand the supplier and client's keys to success, explain the detailed steps of the engineering and procurement phase. So let's take a look at the engineering and procurement phase and what all is involved. Typically, you'll see the process engineering is the first step. That's where designs are validated, long lead POs are placed, and the overall function of the equipment in question is validated. From there, it'll go into project engineering, where equipment data sheets are generated, a piping and instrument diagram is also put together, and additional long lead POs are also ordered during that phase. From there, if applicable, we'll enter discipline engineering, which is the instrumentation, controls. Sometimes you may see pressure vessels, maybe detailed structural skid design. So any specialized engineering will occur after the project engineering phase. There is some overlap during these phases, so that's something to keep in mind. During the design phase, that's when you'll see the 3D model being made, general arrangements. Whoever's involved in that is going to really be putting together the package to make sure it makes a lot of sense and it can be built in the field. Drafting is where the detailed fabrication drawings are then provided to the shop. So let's take a little bit of a deeper look of what's involved in each stage. So process engineering, this is typically what you'll see is something similar to this, a material balance, making sure that the inputs and outputs and what's actually occurring inside that system makes sense. All the different vessels are sized properly, the equipment, the inlets, outlets, it all makes sense from a process standpoint. So some equipment suppliers will not actually have this capability, but if they do, it's always the first thing that's checked. From there, you'll get into project engineering. So project engineering is going to be the process of putting together the piping and instrument diagram. Typically, you'll have a project engineer who works intensely with a drafter to design these P&IDs, and that's really your guidebook for how this entire system comes together. Also, the pumps, motors, vessels, all of those detailed major equipments, you'll see data sheets on that. That data sheet's going to give you a lot of information about the sizing of the equipment, the specifications, all of that type of information. Project engineers will work hand in hand with the client to conduct a hazard and operability study. Typically, that's going to be referred to as an HAZOP. So what happens here is the client and supplier sit down and take a look at each node of this piping and instrument diagram and say, what would happen if it got clogged? What would happen if there was no flow, overflow? All of those types of situations are going to allow us to really dig deep and understand and make sure that this is a safe, operable plant, and it makes a lot of sense. So it's a very important step here in any sort of large-scale custom equipment job. Really, any sort of job that has a piping and instrument diagram. So what you'll see from there, or what you'll see during this initial phase of the project, is a lot of back and forth where the client's going to have specific wants. They'll want tie points. Hey, where is this piping hitting? You've got to remember, a lot of times as an equipment supplier, you'll have a skid that has piping and ties into different spots, different client equipment, and they're going to want to know where they can run their pipes out in the field. So it's not just your equipment, it's actually your equipment is going into typically a much bigger ecosystem. So you also want to be able to provide preliminary GAs, general arrangements. Typically what the client's looking for there is to get an idea of the shipping envelope. That's why you'll also see weights as a requirement as well. So also in this mix, you're going to see discipline engineering. Typically what you'll see here is instrumentation and controls is almost always going to be a discipline that you'll encounter during a custom engineering project. Vessel calculations are also there as well. You'll see that. There are specialized programs that allow you to conduct these pressure vessel calculations according to code. And then structural calculations. A lot of times these are going offshore, and the calculations for that are not trivial. So discipline engineering is going to flow out of the project engineering piece. And it's essential that the project engineers works well with the discipline engineers on developing this. From there, design work happens where the designer needs to be really well briefed in industry and job specific specifications. So that designer needs to sit with the project engineer. The technical team as a unit has to be able to really understand what the function of this unit is. Whatever's being built, does it meet industry code? Does it meet all the specifications? Your project's going to be way better off if the designer is briefed on this. You always want to have a 3D model review whenever required, and eventually your big output out of this phase is going to be certified general arrangement drawings. So what does this look like? How is it all being put together? Anyone technical or non-technical should be able to read those GAs and really get a grasp of what's happening with the project. From there, you'll move on to drafting. So typically drafting are going to be 2D drawings that's going to be supplied to the shop and allow people to build to these drawings. The crucial thing here is to have it back checked by a more senior person, whether that's a project engineer or the designer. It's crucial to have that back checked to ensure that someone who's very familiar with the project is taking a look at the work as well. So let's talk about keys to success during this phase. So from the client standpoint, the engineering procurement phase is the first time sequence part of the project. So what you'll want to do is ensure that all your dates are converted from relative to absolute. You'll be surprised at how often a supplier will continue to say, oh, we'll be able to provide that 3 weeks after such and such. Well, nail down those dates, make sure that it's concrete, everybody understands exactly what's expected, when it's expected, and along the line of dates too, keys to success number 6, make your immediate needs clear. Not everyone's going to know right off the bat that you need the tie points within 2 or 3 weeks. Typically, what I'll see as a supplier is that all of a sudden, hey, we need tie points tomorrow, and it makes it very difficult from a resource perspective to be able to plan for that kind of work. So make sure that your immediate needs are clear. You state them over and over again, and that's continually communicated so that those can be met by the equipment supplier. On the supplier side, what's going to be key is to define the responsibilities of your team. We talked about a lot of different phases happening during this project, and the key is that these phases need to happen in concert. Really bring the team together, make sure that there's a lot of talk back and forth and that it's very clear who is doing what and when. So over communicate. Also, it's easy during this phase to kind of not be as service focused as you may want. A lot of pressure usually at the onset of a project. So just remain service focused and remember that this client has a lot of needs as well, and maybe it doesn't always come through as clearly as you may wish, but at the end of the day, you're working for the client, so make sure to deliver a good product. We're going to go ahead and move on to the fabrication phase.